Hi. Uh, I know that everybody kind of like struggling with traveling microscope because this concept is kind of new because it is not a direct measurement technique, right? So you have to use something really different than you have ever thought of in your O level. So I am going to give you all the very basic details and in detail about how traveling microscope might work. Okay, let's see how it does work.
Here I am going to explain you very important theory.
I would like to give you certain example here. This is the exact measurement technique that we use in traveling microscope. It is kind of different light than vernier caliper, micrometer, screw gauge, and spirometer. Actually, this one there is no direct contact with the read object, so it is a distance method. Imagine that you need to measure certain distance between 2 points on a distance wall. Now you have a laser light and a straight line, and the laser light and the straight edge has a 90-degree angle perpendicular to each other. You can slide the laser light in between. Now have a good look at this position. You target that and mark the reading 1 over here. Right. Now you just slide the light to the other side. Now you just mark it as reading number 2. Now you have completed 2 readings. Now you just need to get the difference between these 2 readings marked on the line here. Marked on the line. Okay. So you took this measurement as R1. You took this measurement as R2. So the difference between this one will be the reading R2 minus R1. Good example, if it was like 15 centimeter here, and this is like 85 centimeter, what is the reading? So the reading will automatically be 85 centimeters minus 15 centimeter. So your reading will be just 70 centimeter. Like that, the traveling microscope use something exactly similar. Okay, traveling microscope has these particular points to consider. Traveling microscope is consisting of certain stage. So the stage is just attached with a certain leveling screw. Using the leveling screw, firstly, you have to just make it vertically balanced and horizontally balanced using a split level, right? There is a horizontal main scale and a horizontal vernier scale. This entire stage, sliding stage, I will show you how can you do it. Okay, so let me give you a good example. Now have a good look at. Now this one, you can keep it on this one and slide to the right and to the left. Whenever you want, you can take a reading. Now at this point, you may mark the reading at here as R1. When you slide it over to the other side, you can mark this reading as R2 reading. So your reading will be R2 minus R1. Always remember, zero line started from here. It just increased in the other side. That is the same way for the vertical. I will explain you here. Now there is a microscope. This microscope you can keep in the horizontal position like this, as well as you can just tilt it over downward and keep it in a vertical position to observe as well. Right. This entire part, including the microscope mount and the vernier scale and the microscope all together, you can move upward and downward. Let me explain you that part here. This one you can just slide up and down. Always remember the zero line start from the bottom. Okay, now you are just going to make the reading of R1 over here, and when you just slide it over to the next position and you read it as the R2, and your vertical height will be vertical length. Vertical length will be what? R2 minus R1 reading. That is how you can take horizontal reading as well as vertical reading from this traveling microscope setup. Okay, then the traveling microscope, it is a microscope. If the image is really blurry, you may have to kind of like focus it exactly how it may appear. So the adjustment is done using this knob and this sliding bar. You can just slide this whole system. There is a um, kind of like screw here, lock screw. You can tighten it and lock it until it won't move. And you take the reading, then you unscrew it, untie, and you can just slide it along this path again. And whenever you want, you can tighten it and get the second reading. But for the vertical one also, there is a lock screw is just behind of this one. That's what's shown over here. Then the microscope. Have a good look at this microscope. You can slide. Okay, microscope. When the microscope is placed, I will show you. You can just slide upward and downward. Good example is here. See, R1 position. That is the R1 position. When you just move it to up, it will raise up to the R2 position. In this way, you can move it up and down. You can bring the whole microscope and the small stage all together, the whole system to the left and right. So typically, you can do what? Take readings in the horizontal to the right or left or the vertically up or down. That means you can cover entire 2D space. If you plot a graph of y-axis versus x-axis, you can take up any coordinate in this system within the marked space of coordinates. Okay, that's it all about. Now I will explain you about the very basic. I have to tell you another thing. When you are about to take reading, there is a certain crosswire inside. The crosswire may look like this way, right? This center is the targeting hair. Now imagine you are going to measure a certain object like this. When you want to keep your objective here, how would you do that? You have to place it exactly on top of, but it is located like this. If you are trying to move this part up or down, holding to here, see, it will move more than the amount you want because you have used a microscope. When you observe a very small capillary tube, the capillary tube image may appear like a very big echelon tube, but actual size is very small when you move by your hand. Actually, in the next time when you try to see, you will see the object is nowhere because why? You have moved too much. When it is come to somewhere like this, you have to use the vertical adjustment knob for moving it up or down, horizontal adjustment knob to move it to the left or right. Now imagine you want to just, it appears to be like downward. I will tell you how. Imagine like you just want to move it down, okay, without considering too much. Okay, you move it down. How to do? You have to raise the adjustment knob a bit slowly, then you can just get the ideal location. You can do the same thing using horizontal fine adjustment knob as well. That's okay. I will tell you why up and down changes. Now have a really good look at the vernier scale may consist of certain following parts. What the vernier scale? Vernier scale is just 49 parts of the main scale. The normally main scale division is like 0.5 millimeter divided into 50 equal parts. So what is the VSD? Vernier scale division is 49 into 0.5 millimeter over 50. Now you want to find out the least count. Least count is MSD minus VSD. Vernier scale division is here, 0.5 minus 49 times 0.5 millimeter, meter here as well, divide by 50. When you solve this, your answer will be 0.01 millimeter. I show you this in the class. I'm not having any interest to explain that again. There is a very straightforward method. That means the least count of the main scale division, you can divide it into the number of divisions in the vernier scale. So in that case as well, 1 millimeter over 100. So that means 0.01 millimeter is the least count. There are two methods to show that. You can use either of these methods. Okay, now I am going to explain you how it may appear when you observe something using a telescope or microscope. It has two types of inversion simultaneously occur. One is the lateral inversion. Lateral inversion means when there is an arrow marked like this to the right, it may appear to be at the left in the image. And the vertical inversion means if there is an arrow like in this way downward, it may appear in the image as an upward one, completely upside down. So the good example is when you write letter D. Letter D may appear like in this way, but the mirror image is something like B. But this one also makes upside down. So the bottom moves up and the top bend like this. Oh, finally, the D appear to be like P because lateral inversion as well as vertical inversion, both together. Okay, I have a better plan to explain you this one. Furthermore, now imagine you just try to take this reading of this type of mercury column. Okay, I will tell you how to get the density of the mercury column in the next video. It will be like just a 5-minute video, which that will be a separate one. You just keep taking the reading of R2 because you should know this left hand side appear to be actually it appear to be like left is not actual left, it is the right. I just explained you. Okay, you just place it. It is actually the reading on the scale. When you just take the reading on the scale, it is like this. This is where the right hand side. The microscope is in the right hand side, but it appears to be like the left. And the other one is you can just reproduce this one. Okay, I'll keep it over here. This reading appears to be like the left. I told you left hand, right hand, just invert. So the lateral inversion. Actually, the microscope is at the left. This is the left. Okay. So the left and right interchange when it appear on the image. Okay. This is how it is. Right. Now let me explain you again one thing. So now you can understand this one directly. This upward thing is not the real upward, it is the down. The down arrow appeared to be, it is not the down of the circumference, it is the upward part of the circumference. Then the right hand side appearing thing is not the actual right hand side thing, it is the left hand side thing. And the left hand side thing is not the actual right hand, it is actually in the right hand side. Okay, now imagine when you just move the point from here to here, actually you are moving the microscope to the left. Even though it appears to be you are moving to right, the real motion in the microscope stage is moving to the left. Okay, now you are just going to move the cross arrow to the upward. The thing is not actually moving to the upward, it is moving to downward. You have to keep these things in your mind. Okay, right. Mm, this is what all about the very basic things that you have to know about micro traveling microscope. Once you understand this one, you can just do whatever you can. Okay, remember one thing: left hand to right hand inversion as upward to the bottom, downward inversion both readily occur in a traveling microscope because it is a microscope. Okay, in the next video sooner I'll come up with the other part called what, how to measure density of a mercury column, or the radius of a, actually radius of a capillary tube using mercury column. This one, the density law. So this part I'll explain you in the next video. Okay.